Hey everybody, how's it going? It's me, Miss Bowman. So I wanted to take a quick moment to make a video about hypothesis testing and help you to create a roadmap that hopefully helps you to see which direction to go when you are using hypothesis testing. So I'm literally going to draw this map for you. I encourage you to take out a pen and a piece of paper and also draw this with me because this could really help you to see what we're going, where we're like what we're doing, where we're going. So I'm over here now, far away. All right. We are using what's called hypothesis testing. This should be pretty clear by now as we keep talking about the null, the alternative hypothesis, but this is formally called hypothesis testing. Now, there are really only two options for hypothesis testing. Either you are going to have evidence for an alternative or the null is true. So we're going to go ahead and write those two avenues. So avenue number one is the null. So the null is denoted by H0, H subscript 0. That is our null hypothesis. Whenever we are providing evidence for the null, what that means is that we have a p-value that is greater than 0.05. What that also means is that P is greater than 5%. What we are saying here is that, let's say you were playing the lottery. If you were playing the lottery, you would want to win, right? Only a small portion of people are going to win the lottery. Everyone else is the null. This person would win, most people would not win by chance, right? You don't want everyone to win the lottery because then not everyone would make as much money. Right? So your P is greater than 0.05. So when you have evidence for your null, you have a P greater than 0.05. This is helpful from the probability calculator from Dr. Falkenberry because this lets you know if it's greater than 0.05, you have the null is true. So what we interpret that as is it's our number above 5%. Or 0.05. So if I have a p-value that is worth 0.06, that is greater than 0.05, hence the null is true. This would lead us to fail to reject the null. This is an odd way of wording it, right? Fail to reject, we can't reject, we fail to reject. But this is the terminology that is pretty standard amongst hypothesis testing experts and students. So this is what we are going to use as well. Well, following the failure to reject the null hypothesis, we conclude that there was no effect. So no effect of the treatment that they were given, no effect of the intervention that they were given, no difference between two groups, etc. So that leads to the final conclusion of no difference between our mu and our x bar. So there's no difference between our sample and our population means. There's no difference between our two groups. What we are investigating is not different. So I'm going to go ahead and also up here write mu is equal to 0 because that's normally our hypothesis. That's normally traditionally how we write that. I forgot that, excuse me. All righty. On the other hand, we have our alternative hypothesis. Our alternative hypothesis looks like the following. So I'm just going to shorthand ALT for alternative, but it is our H1, and mu is not equal to 0. Now we're going to take a really quick caveat with this as well, because we have a couple of different ways that we can look at this. Either mu is just not equal to 0, hence we would have a two-tailed test, or we would have a directional hypothesis. So we're going to call this one non-directional We're going to call it a two-tailed test. That literally means that on the normal distribution, we have our two tails that we expect the effect to be in, or we're looking for it in these two small portions at the end of the distribution. On the other hand, we can have what's called a one-tailed test. It would either look like this. So an H1 of mu is greater than 0 or mu is less than 0. This is known as a directional hypothesis. And so we would expect that it's either all the way to the right or all the way to the left. Directional hypotheses can be super important, so please understand the difference between non-directional and directional hypotheses. What are we looking for? What area of the curve are you trying to find information about? So then, for our alternative hypothesis, we expect that P is less than 0.05. A lot of students ask me, well, where did this 0.05 come from? This is what is set by our field. If it is not by chance, then we would expect that it is less than 0.05. So what that means is that 95% of the curve is attributed to chance. Just happened, right? Our effects, there isn't one because it's just chance. But whenever it's in one little itty bitty corner or one itty bitty little tail, or both of the little itty bitty tails, we're saying that it's more than by chance, that there is an effect. We're not just picking straws and picking an effect, right? It's more than by chance. We have an actual finding. So again, just to reiterate, this is the number is below, or the p-value is what I mean by the number. So below 5% or 0.05. Awesome. So after we've set our hypotheses, we solve. So we solve. After we solve, we say, okay, is it greater than 0.05 or is it less than 0.05? Either way, whatever our findings are, we determine if it's above or below 0.05. If it's below 0.05, then we move forward in our alternative testing and we say that we can reject the null. Yay, we can reject it. We have evidence of an effect. So I'm going to put just the word effect right here. Another thing we need to put in here is rare versus plausible. So I'm just going to make a little note. So I'm going to make it right here. Rare. These are the words that we've been using in this course, and this one is plausible. This is saying that it is plausible that the null is true. We can't provide evidence for the null, but we can say that it's plausible that the null is true. But what we really want to do is we want to say that our results are rare. So we have evidence of an effect. Our treatment worked. There is a difference between two groups. We can lastly say that there's a difference between mu and x bar. And then I finally want to tell you that the whole purpose of doing this, or one of the tools, is that we are solving for the potential of the null to provide evidence. So, excuse me, evidence of H1. Please make sure that you go and draw this for yourself. This little diagram I've found to be helpful in my other courses that I've taught. Thank you for watching this video, and I hope that you're enjoying the course. If you're having any issues, please make sure that you reach out to me via email or that you are communicating with me to let me know that you need some assistance. And I will talk to you later. Bye now.